Okay, guys, shall we start then? So all of you keep your data handbooks ready. As I told you in the last class, even your calculators ready. Okay. So this particular problem has to be completed within a span of 1 hour. So be quick. I may ask anyone in the middle of the online class to just switch on your camera and show up what you are doing. Okay. Any issues to solve the problem, you can let me know before I start. Okay. Is the voice clear enough? Any problem with the voice? Data same. Okay. Okay. Now, if I just come closer and talk, it's better. Can you hear me?
Yes, sir.
Okay, then. So I'll try to speak a little bit louder so that you can hear me. Okay. So hopefully you have taken this particular problem. I will directly start and make sure you're logged in your laptop. Okay. Have your data handbooks with you, have your calculators with you, and have your notes with you. Okay. So as and when I solve the problem in the same pace, even you have to solve. Then only you'll get to know the things. Okay. Said that, we'll start the problem. So given data. So just read out the question. In a spur gear arrangement, in the sense it's a problem on the spur gear. Okay. That's great arrangement. A pinion is made up of. So again, there's a bifurcation or the data given for the gear as well as for the pinion. So what we have to do is just draw a gear, draw a pinion there. Okay. Now, the pinion made up of cast steel. So this is the pinion which I'm talking about. Pinion, and this particular material he has mentioned it as cast steel. Okay. Next is rotating at 900 RPM, he says. So I would take this as 1 and this as 2. Okay. It depends on you how you take it. That doesn't make a difference. It's just for the notation. Okay. So N1 is equals to 900. So pinion is rotating at 900 RPM. That's great. It's driving a cast iron gear. So this is made up of cast steel, but the gear is made up of cast iron, he says. Okay, just write it down, cast iron, and it is rotating at 150 RPM. The gear is rotating at 150 RPM. The teeth are to have standard 20-degree stub involute profile. So he has given the information about the teeth which is engaging. So you just write teeth on the either side and just write 20-degree involute stub. Okay, just write 20-degree involute stub. Next. And the maximum power to be transmitted is 25 kilowatts. So power which is to be transmitted, take it as 25 kilowatts. Next, determine the module and the phase width. So to find, what you have to find is, to find the first one, you have to find the module which is being questioned. Second is the phase width which is being questioned. Okay. The pinion has 16 teeth. Find the dynamic and the wear load also. So he has asked us to calculate FD, which is third. And the fourth one is FW, also wear load. I think we are calculating for the first time, isn't it? Wear load. Am I right? last problem we have calculated dynamic load. Okay, fine. So the pinion has 16 teeth, he says. So Z1, I would be rating it as 16. Okay. Next, the surface hardness he has given. So I would rate it as Brinell hardness number. Okay, Brinell hardness number for 1 is given as 250 for the pinion. Take static stress for the pinion as 103. So design stress for the pinion, he has given it as 103. Okay. 250 BHN, just write the units if possible. It is 250 BHN and the static stress is 103 megapascal. Okay, that's fine. And what else is given? The static stress of the pinion, and for the gear he has given, so sigma D2, the value is 55 megapascals. That's great. Next, what else he has given? For the gear, so assume Young's modulus he has given for the pinion as well as for the gear. So for the pinion is E1, which is equal to 96 giga Newton per meter square. That is the unit which he has given. E2 is equals to 207 giga Newton per meter square. Okay. Any of the parameter which is being mentioned in the question but not being listed here? Just read the question, everyone. Any such parameter which is being given in the question but not being listed here?
I equals to N2 by N1.
Okay, that we need to calculate, I guess, right? But whatever which is mentioned in the question, I think most of the things I have written, I have not, left nothing. So shall we set up with the solution? Yes.
Yes, sir.
That's great. Now, so first, as Radvik said, we will calculate the value of I, which is velocity ratio, which is given by N1 by N2. Okay. So N1 by N2 in the sense N1 is 900 divided by N2 is 150. So velocity ratio is 0, 0 get cancelled, 15 over 15, 6. So I guess it is 6. Am I right?
Yes, sir.
So once I is known, even I is given as Z2 by Z1. Okay. So from this, you can calculate the value of Z2, which is given as I into Z1, that is equals to 6 cross 16, that is equals to 16, 6, 96 teeth. Even the value of Z2 can be identified. Okay. Now, once the preliminary calculations of velocity ratio and Z2 is done, what is our first step? Before I calculate the module for this, what is our first main step?
Strength factor.
Why we need to do that? What is the reason to calculate the strength factor? Yes.
Weaker part. Weaker part, sir.
Correct. So we need to find the weaker part. So we'll calculate ಮಾಡಿ identifying the weaker part. ಹೇಗೆ identify ಮಾಡ್ತೀರಾ? You already know it. Please do it and give me the weaker part as fast as possible. Now we are trying to identify the weaker part, and this particular thing would be based on the strength factor, as I said. So what is the strength factor? The strength factor is nothing but it is sigma d, sorry, not sigma y, the sigma d cross y. And what is y? Y is equal to, where is the expression for the y?
12.5 D.
Excellent. Good look into the data. Just look at the teeth profile, what he has given, 20-degree involute stop. For this, get the equation, right equation. So here it is. So which I should take? Which equation should I take it here? 12.5C or 12.5D or 12.5E?
12.5D.
D or E?
D.
E.
There you go wrong. So carefully observe what he has given there. He
E,
has
sir.
given 20-degree stub. Okay, it's for the stub speed system. So this is the equation you must take. Be careful about this. Okay, so which equation you must take here is the
E.
equation number 12.5E. Exactly. Just take that from your equation. It says 0.175. 0.175 minus 0.95 divided by Z. So this particular equation you have taken from equation number 12.5E on the page number 204. Now, quickly calculate the value of Y1, quickly calculate the value of Y2. So it is 0.175 minus 0.95 divided by Z1 value was 16. 0.175 minus 0.95 divided by Z2 value was, I think, 6 times, so 9 to 6. What is the value? Y1 and Y2. What is the value? Yes, Nitish Kumar. 0.115 is the value for which one?
Y1.
0. Okay, 1 is 5. Y1 and Y2 is there. So now go for sigma D1 cross Y1 value and sigma D2 cross Y2 value. Just substitute the things as sigma D1 supposed to be 103 into 0.115. Here it is 55 cross 0.165. So the values, upon this values, you are going to decide which one is weaker based on the lowest value, whichever you get. Yes, give me the values fast. Maruf. Muhammad Maharoof. Okay, 11.9 and 9.08. 11.9 and 9.08. So gear is weaker.
Yes, sir.
Okay, so just write since strength factor of gear is lesser, whatever you want, you can write it. Okay, therefore, design is based on the gear. Now, whatever parameter you choose for the calculations, it has to be entirely the gear. Okay.
Isn't it pinion?
Yes.
Okay.
Mera
No,
opinion.
think.
No, sir. Correct.
Correct untalla. Next ಏನು ಮಾಡಬೇಕು ನಾವು? What should we do? So we have decided gear is a vehicle. So we will start to find out the parameters. So which parameter would you find first? Module. So module, find out ಮಾಡ್ಲಿಕ್ಕೆ what is the equation? So take it from the equation m is equal to cubed root of 2 times of mt divided by sigma d cross cv cross k cross y cross z. So istella ramayana ide. So where you have taken this particular equation, it is equation number 12.5. ಏನೋ ಬಿನೋ ಸೀನೋ ಇದೆ, ಅದು ನೋಡ್ಕೊಂಡು ಬರ್ಕೊಳ್ಳಿ. Page number 204. Okay. Next, calculate one by one. Now, mt. How will you calculate mt? Go for the power equation. P is equals to 2 pi gear or pinion. Gear is it? So therefore, N2 into mt divided by 60. Now, substitute it. P is nothing but 25 kilowatts. So 10 to the power of 3, that is equals to 2 pi cross N2 is 150 cross mt divided by 60. From this, what is the value of mt I've got? So whatever you get, that would be in Newton mm.
1591.5.
1591.
0.5.
0.5 Newton mm. Be careful about the units. Is this correct? Newton meters. No, I want it in Newton mm. So into 10 to the power of 3. Now it is correct. Yes, good. Now mt is done. Next, sigma d. Sigma d, you know the value, I guess, right? Sigma d of 2 is nothing but how much? 55 and 55 megapascal. Okay. Sigma d is done. Cv, is there any chance through which I can pick up the velocity factor? Is there any chance through which I can calculate my velocity factor? For velocity factor to be calculated, we have to refer the Bart's formula, which is these formulas we have to refer. For this, you require the value of V. For calculating V, you require pi d n by 60. Now you know the value of n, but you don't know the value of d. So since you cannot calculate the velocity, you cannot calculate the velocity factor, isn't it? Correct? So if the velocity factor cannot be calculated, what you have to do?
Assume.
Exactly. So how much you're going to assume it?
0.5.
0.5. Very good. Next, CVI2, the value of K. So K is nothing but, it is B by M. Phase width is unknown, everything is unknown. So what do you have to do here? Again, you have to assume. Assume B by M, how much? What is the standard procedure that we follow? 10. Very good. Now, next is the form factor, which is the capital Y. So capital Y, it is pi times of y2. Since it is design is based on gear here, so it is 0.1651, which is the value of y2, I guess. Correct? Am I right? Just check this value. 165. So 165 into pi. So this is the value of y2. Now I guess everything is data is being calculated. Missing data was assumed. Now you calculate the trial module first. Just substitute all the things in equation number 12.5 and give me the trial value of this thing, module. Okay. So it is 2 times of MT should be substituted in Newton mm. So 1591.5 cross 10 to the power of 3. This whole divided by, let us 55, you have to substitute in LPA. Take care about it. 0.5 is velocity factor. Cross 10 is B by M K, which is cross 0.1651 into pi cross 96. What is 96? Is the number of teeth there, Z2. So I would write Z2 parameter here. Okay, 96. Very good. So now you give me the module based on our initial calculations. What module?
6.15.
How much? 6.15 mm. Now, what is the next step? Once I got the module, what should I do? Have to immediately jump into the table number 12.2, which is at the page number 229. For what purpose? What is the purpose I have to look into this particular table?
Standard value.
So standardizing the above value. Standardizing above value. Okay. Madri standardize ಮಾಡಿ ಹೇಳಿ ನನಗೆ. What is the final M you are going to give me? Standardize it. Go for table number 12.5, sorry, 12.2, page number 229. H. Okay, Mohammed says. So, in which column you have preferred, or you gone with the choice 1 or choice 2? Which column you have picked up the value? Mohammed Saad.
Preferred.
Preferred. Okay. So let us all of us fix on to this particular value. 8 mm. 6.5. Okay. 6.5 in which one?
Choice 3.
Oh, choice 3, then it is not feasible, I guess, right? At least choice 2 would be better. Any other suggestions? 7, where it comes? Where it comes?
Choice 2.
Choice 2. Okay. Okay, you can check for choice 7. Okay. You can go with module number 7 and check for the same thing where you have thank you. Okay, you can go with
ಹೇಳ್ತೀರಾ ಸರ್ ಅದು ಹೇಗೆ ಇದು ಮಾಡೋದಂತ
ಯಾವುದು
ಸ್ಟ್ಯಾಂಡರ್ಡೈಸ್
ಮಾಡೋದು ಹೇಗೆ ಅಂತ. ಓಕೆ ಟೇಬಲ್ ಹೋಗಿ ತುಂಬಾ ಮುಂದೆ ಹೋದೆ. 229. ಇಲ್ಲುಂಟು, ಇಲ್ಲಿ ನೋಡಿ. ಸೊ ವಾಟ್ ವಾಸ್ ಅವರ್ ವ್ಯಾಲ್ಯೂ? 6.15. 1.5.
6.1.
Okay. So you have to look in this particular amount of modules which is given by the manufacturers. Okay. 6.15 L ಬರುತ್ತೆ ಒಂದು 6 ಇದೆ. We cannot go for the lower value. That is for damn sure. You have to go for higher value. One thing you keep in mind, you should never, if it was 0.1 also, never go for the lower value. It is always preferred for the higher value, isn't it? Now we have to go for either 8 or 7. Okay. 8 is more satisfying than 7. Okay. Why? Because two reasons. Number one is it is more preferred. It comes in the preferred column. ಇದು ಹೇಗೆ ಅಂತಂದ್ರೆ ಇದು ಆಡಿ ಇದ್ದಂಗೆ. ಓಕೆನಾ? ಇದು ಒಂಥರ ಜನರಲ್ ಮೋಟರ್ಸ್ ಗಾಡಿ ಇದ್ದಂಗೆ. Next it is Maruti Suzuki. So which vehicle would you prefer? First, when you have three vehicles in front of you, Audi ಇದೆ, ಒಂದು ಜನರಲ್ ಮೋಟರ್ಸ್ ಇದೆ, ಇನ್ನೊಂದು Maruti Suzuki ಇದೆ. ಯಾವ ಗಾಡಿ ನೀನು ತಗೊಳ್ತೀಯ ಫಸ್ಟ್ ಗೆ? ರಾಜ್ವಿಕ್ ನಿಂಗೆ ಕೇಳ್ತಾರದ್ ನಾನು.
ಯಾವ್ದು ಗಾಡಿ ಸರ್?
So when you have Audi in front of you and a General Motor which is Bangalore manufactured and one more is the Maruti Suzuki. So three brands din ಮುಂದೆ ಇಟ್ಟಿದ್ದಾನೆ. ಯಾವ್ದು ಫಸ್ಟ್ ಪ್ರಿಫರೆನ್ಸ್ ಕೊಡ್ತೀಯ?
Audi sir.
Definitely Audi, isn't it? So because it is more preferred, more reliable. So what we will do is, in always the design procedure, we would follow a preferred value. It doesn't mean that you have to not use the choice 2 or nor you have to not use the Maruti Suzuki one. It can be used, but when you have a preferred choice, you should go with the preferred choice. Okay. Now, there are two ways, Radhik. One, you 8 adru decide madbodu, or you can go with the 7. It's up to you. Okay. So if you go with the 7 or if you go with the 8, finally, next step immediate to. Once I standardize the value, what is our next step? Since we have assumed the value of CV, since we have assumed the value of face width, what is our next step? We need to check for the stress, isn't it? Correct? Yes. So, alli check ಮಾಡಿದಾಗ suppose ನಿನ್ನ value satisfying ಆಗಿ ಬಂತು. ಓಕೆನಾ? ಅದಕ್ಕಿಂತ ಕಮ್ಮಿ ಇತ್ತು. Applied design stress ಕಿಂತ ಕಮ್ಮಿ ಬಂತು applied stress value ಅಂತಂದ್ರೆ, then your preferred value is correct. Correct?
Okay.
So that is how it works. So you can split now. Someone of you go with the 7, someone of you go with 8. It's up to you guys. So learn the design procedure. That is what I'm talking about. Learn it. So someone of you choose 7 and someone of you choose 8. And just check the design procedure. And I would go with 8. Okay, because it is higher value. ನನ್ನ ಕೇಳಿದ್ರೆ ನನ್ನ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ನಾನು ಹೇಳ್ತಾನೆ, always I would go with the higher value. Two advantages ನನಗೆ ಕಾಣಿಸ್ತಾ ಇದೆ. The first advantage is it is a higher value. Second advantage is it is more preferred. It is in the preferred column. I would select Audi rather than a General Motor. In that sense, I would go with 8. Someone of you try with 7. Let us see. I would go with 8. Okay. How to check now? So what you have to do? You have to standardize it as 8. Standardize ಮಾಡಿದ್ದೀರಾ? What is the next step? Since CV was assumed, okay, since CV was assumed, you have to check for the design stress. Now, FT, for that you have to take the tangential load equation, pi sigma d CV b m and y. So all these parameters you require for that. Before to that, you have to calculate certain parameters. The PCD of pinion, which is given by D1, is equals to m times of Z1. Just calculate and give me the value. PCD, whoever is solving for 8 can help me with the values. Okay. PCD of gear, and some of you please try with the value of 7. So how many of you are trying with the value of 7? Let me know now. Raise your hands. With the 7. Value of 7. How many of you trying it? Nitish Kumar, okay. Only one? Only one? Oh. Rishikesh.
Yes, sir.
Try with 7. Try with 7. Don't go with 8. Irwin. Irwin. Mithun Naik. Muhammad Azhar.
Yes, sir.
So all of
They're
you try
already
with
8
7.
men.
ಓಯ್ ಸುಮ್ಮನೆ 7 ಮಾಡ್ರ ಯಾರು ಎಲ್ಲರೂ 8 ಮಾಡಿದ್ರೆ ನಂದನ್ ಮೊಹಮ್ಮದ್ ಆಮೇರ್ ಮೊಹಮ್ಮದ್ ಆಮೇರ್ ಮೊಹಮ್ಮದ್ ಆಮೇರ್ ಇಲ್ಲ ಅನ್ಸುತ್ತೆ ಅವನಿಗೆ ಆಬ್ಸೆಂಟ್ ಆಗ ಮೊಹಮ್ಮದ್ ಆಮೇರ್ ಓಕೆ ಮೊಹಮ್ಮದ್ ಆಮೇರ್ ಏನು ಕಾಣ್ತಾನಿಲ್ಲ ಇದರಲ್ಲಿ. So all of you, some of you, please try with Ruben. With what value you are trying?
7, sir.
7. Good, good, good. So those are trying with 8. Please give me the values. D2 is equal to m times of Z2. That is equal to. Next is face width you need to calculate. So face width is B, which is 10 times the module. Okay, give me all these values, guys. Anyone? PCD of pinion, D1, D2, and D. $128, $768, and $80. So I guess all are in M. Yeah, man. So once that is done, so immediately calculate the value of V, which is pi D2 N2 divided by 60. That is in turn equal to so pi cross D2 value was 0. Substitute in meters, so 0.678 cross N2 value was how much? N2 150 divided by 60. So once you calculate it, it would be around 6 meters per second. So for 6 meters per second, go for the Bart's formula. Again, I have to scroll down. So look for the Bart's formula. 2 to 3 formulas could be there. Okay. For that particular segment, which is the formula applicable, you can just check. I have the data handbook here. I'll take it from there. Okay, so it is 3.05 divided by 3.05 plus V. And this is the formula for V less than 8 meters per second. So this is equals to, just substitute the value of V, whatever you have got, plus 6. So the value of CV would come around, value of CV
0.33.
0.33. So it is 0.33. So once that is done, I have told you in the last class, how do you calculate the value of Ft? It is 2 times the torque divided by 2. And even I have told you how this particular thing has been arrived. Okay. So just substitute the things. 2 times of torque is 1591.55 into 10 to the power of 3. So this whole divided by 76.8. So what is the value of Ft you have got? $768 Canada. ಅಲ್ವಾ?
Yes, sir.
768. FT ಎಷ್ಟು ಬಂತು? Okay, 4144. 4144.66. Since that is calculated, now go with that particular equation there. So FT is 4144.66. That is equals to pi into sigma d2. That is the thing which you are which you are calculating now. So just keep it pi times of d2 cross CV value at is 0.33 around cross B value ಅಂದ್ರೆ 80 cross Y value Y1 ಅಲ್ಲಿಂದ ತಗೋಬೇಕೇನೋ. Okay. 0.1651 cross M value which we have selected is 8. From this sigma D2. So whatever you get the value, that has to be less than 55 megapascal. So that is our target. That is what we are checking for. $37.85. Okay, 37.85, and this is for 8 megapascal. I mean, not 8 megapascal. Another 8 mm module. 7 mm module is ಎಷ್ಟು ಬಂತು? That is the thing where I'm curious upon.
76.32.
And remember, I would just write here 76. Sorry, 1 ನಿಮಿಷ ತಾಡು. And this is for 8 mm module. Correct? 8 mm module. ಇದೇ ತರ ಇಲ್ಲೊಂದು ಬೇರೆ ಕಲರ್ ಅಲ್ಲೇ ಬರ್ಬಿಡ್ತಾನೆ. Sigma D2 when calculated for what you can say 7 mm module. ಎಷ್ಟು ಬಂತು ಮಿಥುನ್?
76.32.
26
76.
76.
ಶಾಕ್ ಆದ್ನಲ್ಲೋ 26 ಅಂದ್ರೆ ತೊಂದ್ರೆ ಇಲ್ಲ. 76.32 ಮೆಗಾಪ್ಯಾಸ್ಕಲ್. ಕರೆಕ್ಟಾ? ಈಗ ಹೇಳಿ, ಸಪೋಸ್ ಇವಾಗ ಯಾರಾದ್ರೂ 7 ತಗೊಂಡಿದ್ರು ಅನ್ಕೊಡಿ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ. ಸೊ ಯಾರ್ಯಾರು 7 ತಗೊಂಡಿದ್ದೀರಾ ಅವರೆಲ್ಲ ಏನ್ ಬರಿತಾ ಇದ್ರಿ ಸ್ಟೇಟ್ಮೆಂಟ್? ವಾಟ್ ಕುಡ್ ಹ್ಯಾವ್ ಬೀನ್ ರಿಟನ್? ಏನ್ ಬರಿತಾ ಇದ್ರಿ ಸ್ಟೇಟ್ಮೆಂಟ್? ಮಿಥುನ್, ಐ ವಾಂಟ್ ಯು ಟು ಆನ್ಸರ್ ದಿಸ್. ಈಗ 76 ಬಂತು, which is not less than 55 megapascal. Definitely it is way ahead than 55 megapascal, which is allowable stress or design stress. So what is our next step?
6.5.
Nth of 6.5.
ಅಲ್ಲ, ಲಾಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಹೇಳಿದ್ರೆ ನಾವು ಡಿಕ್ರೀಸ್ ಮಾಡಿದ್ರೆ
ಸರಿ, ರೆಫರ್ ಮಾಡು ಲಾಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಅನ್ನು. ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಬೇಕು. ಸೊ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದ್ರೆ ಎಲ್ಲಿಗೆ ಬರ್ತಾ ಇದ್ದೀನಿ ನೀನು ವಾಪಸ್? 8. ಅರ್ಥ ಆಯ್ತಾ Radvik? Now you got a clear picture, I guess. It's all about choosing the right value and checking it. Aste.
Yes, okay.
ಸರ್ ಅದು ಪ್ರಿಫರ್ಡ್ ವ್ಯಾಲ್ಯೂ ತೆಗೆದ್ರೆ ಎಂತ ಆಗ್ತದೆ? ಎಲ್ಲದಕ್ಕೆ
ಏನಪ್ಪ
ಪ್ರಿಫರ್ಡ್ ವ್ಯಾಲ್ಯೂ ತೆಗೆದ್ರೆ ಎಂತ ಆಗ್ತದೆ?
ಪ್ರಿಫರ್ಡ್ ನೋಡು, ಇಲ್ಲಿ ಏನ್ ಗೊತ್ತಾ, ಪ್ರಿಫರ್ಡ್ ಚಾಯ್ಸ್ ಅಂತ ಅವ್ರು ಕೊಟ್ಟಿದ್ದಾರೆ ನಿಜ. ಬಟ್ ಅಲ್ಟಿಮೇಟ್ಲಿ ನಿನ್ಗೆ ಏನ್ ಗೊತ್ತಾ, ವಾಟ್ ಎವರ್ ಚಾಯ್ಸ್ ಯು ಹ್ಯಾವ್ ಮೇಡ್, whether we have taken from preferred, whether you have taken from choice or choice 3, it doesn't matter. Nanige matter agodenu, whatever the value of module you have selected, with that applied stress value, allowable stress value kena kammi barabek aste ನನ್ನ ಫಂಡ. ಕಮ್ಮಿ ಬಂತ, select that value, no issue. Getting my point? ಕಮ್ಮಿ ಬಂದಿಲ್ವಾ, ಸಪೋಸ್ ಜಾಸ್ತಿ ಬಂತು, ಅವಾಗ ವಾಟ್ ಯು ಹ್ಯಾವ್ ಟು ಡೂ, ಯು ಹ್ಯಾವ್ ಟು ಗೋ ವಿತ್ ದ ಹೈಯರ್ ವ್ಯಾಲ್ಯೂ. ಸಪೋಸ್ ನಾನೀಗ ಹೇಳ್ದೆ ನಿಮ್ಗೆ ಪ್ರಿಫರ್ಡ್ ವ್ಯಾಲ್ಯೂ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ 8 ನಾನು ತಗೊಂಡೆ ಅಂತ. I have taken 8 and someone of you have taken 7. What if in spite of selecting 8, I could not get less than 55? ನಾನು 8 ಸೆಲೆಕ್ಟ್ ಮಾಡಿದ್ರು ಸಹ 55 ಕಿಂತ ಕೆಳಗಡೆ ಬಂದಿಲ್ಲ ಅಂತಂದ್ರೆ what is my next action? Increase the value. Again, you have two choices to make there. Either you can go with 9 or you can go with 10. ನೀವೇನ್ ಮಾಡ್ತೀರಾ? ಇಂಟೆಲಿಜೆಂಟ್ ಆದವರು, ಸ್ವಲ್ಪ ಸ್ಮಾರ್ಟ್ ವರ್ಕ್ ಮಾಡಿದವರು, what will you do? Will you go with 9 or will you go with 10?
10.
Why? Because ಇವಾಗ ನೋಡಿ 9 ಹೋಗಿ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಿ ಸಪೋಸ್ ಕಮ್ಮಿ ಆಗಿಲ್ಲ ಅನ್ಕೊಳ್ಳಿ, ಓಕೆನಾ, ಡಿಸೈನ್ ಸ್ಟ್ರೆಸ್ ವ್ಯಾಲ್ಯೂ ಕಿಂತ ಕಮ್ಮಿ ಆಗಿಲ್ಲ ಅನ್ಕೊಳ್ಳಿ, ಅಗೇನ್ you have to go for 10, no, rather than directly go with 10. This is how the practice of the gears will make you to choose the right module. It's all about nodu. Neen yavde module tagondru no problem. If you check with choice 3 also, it doesn't even matter for me. What really matters is for that particular module with what you have selected, the stress what you are developing with that particular module should be less than the allowable stress, and that is my primary criteria. If that is satisfied, everything is satisfied. Got it? Any doubts here?
No, sir.
Everyone clear about this? Rishikesh, you did not respond me when I called you. This fellow is not there. Rishikesh.
Sir.
Sir,
Arif, head.
Like what if both the 7 and gave less rather than 55?
That is what I was talking about initially. If say 7 and 8 also not meet our criteria, so what you have to do, you have to increase the value till your applied stress value would come less than the allowable stress value.
What if both gave
Both get
less than 55?
question ಅರ್ಥ ಆಗ್ತಾ ಇಲ್ಲ ನಂಗೆ.
So like you chose 8 and we chose 7, and
Exactly.
both values we got less than 5, like 55. Then
Superb question. Abaga, I would say you, Arif, listen here. So you have taken 2 amount of gears, okay, or 2 amount of modules you have calculated as a design engineer, okay, and both the values, for example, ಈ ಕ್ವೆಶ್ಚನ್ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, ಆರಿಫ್ ಕೇಳಿರೋದು ತುಂಬಾ ಚೆನ್ನಾಗಿದೆ. Both the values, suppose 8 and 7 are very much less than 55. Then which to choose is the question. Okay, being a design engineer, a 7 mm module gear costs, say it is 150 rupees, and 8 mm module gear would cost around 350 rupees. Okay, as the module of the gear increases, definitely the cost increases. Keep this in mind. Now, as a design engineer, which one will you choose, Arif?
7, sir.
That is how you have to come on a decision. I think I have answered your question, right?
Yes, sir.
That's it. So ನೀವು one point ಇದು ಯಾರಾದ್ರೂ ಕೇಳ್ತಾರೆ ಅನ್ಕೊಂಡಿದ್ದೆ, ಆಯ್ತು ಸರ್ ನಾನು ಮಾಡ್ಯೂಲ್ ನ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಕೊಂತಾನೆ ಹೋಗ್ತೀನಿ, ಅದ್ರ ಬದಲು ನಾನು 7 ಟ್ರೈ ಮಾಡಿ 8 ಗೆ ಟ್ರೈ ಮಾಡಿ, ಐ ಮೀನ್ 7 ಟ್ರೈ ಮಾಡಿ ಲೇಟರ್ 8 ಟ್ರೈ ಮಾಡಿ ಮತ್ತೆ 9 10 ಇಷ್ಟೆಲ್ಲ ಮಾಡೋ ಬದಲು ಒಂದ್ 4-5 ಸ್ಟೆಪ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿ ಡೈರೆಕ್ಟ್ 20 ಗೆ ಟ್ರೈ ಮಾಡ್ಬೋದಲ್ಲ. Correct? You can go for 20, no? It will reduce our design calculations. But ನೀನ್ 20 ಹೋಯ್ತು ಅಂದ್ರೆ ನಿನ್ ಗೇರ್ ದ ಕಾಸ್ಟ್ 1000 rupees ರೀಚ್ ಆಗಿರುತ್ತೆ. Then you are not effective design engineer. Got my point, everyone?
yes, sir.
That is the way you have to choose, and that is the beauty of this particular subject. Okay.
ಸರ್
Now, ನಿತೀಶ್ ಹೇಳು.
ಸರ್ ಅದು M7 ನಾವು ತಗೊಂಡ್ವಲ್ಲ ಈಗ,
ಹಾ.
ಅದಕ್ಕೆ ಅದು ಲಾಸ್ಟ್ ಇದ್ದು ಸಿಗ್ಮಾ ಡಿ ವ್ಯಾಲ್ಯೂ 50.9 ಬರ್ತದೆ ಸರ್ ಈಗ.
ಯಾವ್ದಪ್ಪ?
ಅಲ್ಲ, ಎಂ ವ್ಯಾಲ್ಯೂ 7 ತಗೊಂಡಲ್ಲ ನಾವೀಗ 8 ಸಾಲ್ವ್ ಮಾಡಿದ್ರಲ್ಲ.
ಹೌದು, 7 ತಗೊಂಡಿದ್ಯಾ ನೀನು?
ಸಿಗ್ಮಾ ಡಿ ವ್ಯಾಲ್ಯೂ 50.9 ಬರ್ತದೆ.
50.9 ಬರುತ್ತಾ? ಮತ್ತೆ 76 ಅಂತ ಹೇಳಿದ್ರು.
50.9 ಬರ್ತದೆ ಸರ್, ಅದು ಮೋಸ್ಟ್ಲಿ ರಾಂಗ್ ಅಂತ. ನಮ್ಗೆ 50.9 ಬಂತು.
ಹೌದಾ? ಈ ಚೆಕ್ ಮಾಡಿ, ಇದು ಯಾರು ಕೊಟ್ಟಿರೋದು ವ್ಯಾಲ್ಯೂ 76.32?
ಸರ್ ಅದನ್ನು CS ಮಾಡಿದೆ. CS ಸರ್ವಿಸ್ ಫ್ಯಾಕ್ಟರ್ ಲಾಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ 1.5 ಅಂತ ತಗೊಂಡಿದ್ರಲ್ಲ, ಇದಕ್ಕೂ ಕೂಡ ತಗೊಳ್ಬೇಕಂತ.
ಅಲ್ಲ, ಅವ್ನು ಮೆನ್ಷನ್ ಮಾಡಿಲ್ಲ ಅಂತಂದ್ರೆ ತಗೊಳ್ಳೋದು ಬೇಡ. ಏನಕ್ಕೆ ತಗೊಳ್ಳೋದು? ಹೌದಾ? ಸೊ ಇಫ್ ಹಿ ಹಸ್ ನಾಟ್ ಮೆನ್ಷನ್ ಇಟ್, ವೈ ಟು ಟೇಕ್ ಇಟ್ ಅಲ್ವಾ? ಹಾಗಿತ್ತು ಅಂತಂದ್ರೆ ಸಪೋಸ್ ಇವಾಗ ನನಗೆ ಎಕ್ಸಾಕ್ಟ್ ಆಗಿ ಆನ್ಸರ್ ಕೊಡಿ, 7mm ಮಾಡ್ಯೂಲಿಗೆ ಹೇಗೆ ಫಿಕ್ಸ್ ಆಗ್ತೀರಾ ಅಂತ. ಐ ಮೀನ್, ವಾಟ್ ಇಸ್ ದ ಎಕ್ಸಾಕ್ಟ್ ವ್ಯಾಲ್ಯೂ, ವೆದರ್ ಇಟ್ ಇಸ್ 76.3 or it is 50.9?
50.9.
If it is 50.9, then you can go with 7mm module, nothing wrong. ಅರ್ಥ ಆಯ್ತಾ? 7mm module you can fix upon, no issue. No doubt ಅದರಲ್ಲಿ. ಓಕೆನಾ?
50.9 ಸರ್.
50.9 ಬಂದಾಗ you can go with 7mm module dear, no issue. ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ, ಯು ವಿಲ್ ಗೆಟ್ ಯುವರ್ ಮಾರ್ಕ್ಸ್. ಅಂಡ್ ಇನ್ನೊಂದು ಯೋಚನೆ ಮಾಡ್ತಾ ಇರ್ತಾರೆ ಈ 8mm ಮಾಡ್ಯೂಲ್ ಮಾಡಿದವರು. 8mm ಮಾಡ್ಯೂಲ್ ಮಾಡಿದವ್ರು ಏನು, ಅಯ್ಯೋ ನಾನು 37.85 ತಂದಿದ್ದೆ, ಇವ್ರು ನೋಡಿದ್ರೆ 7mm ಮಾಡ್ಯೂಲಿಗೆ ಫಿಕ್ಸ್ ಆಗಿದ್ದಾರೆ, ನಾನು 8 ಮಾಡಿದ್ದೀನಿ, ವೆದರ್ ಇಟ್ ಕುಡ್ ಬಿ ರಾಂಗ್ ಆರ್ ರೈಟ್ ಅಂತ ನಿಮ್ಮ ಮನಸ್ಸಲ್ಲಿ ಡೌಟ್ ಇರುತ್ತೆ. ಇನ್ ದಾಟ್ ಕೇಸಸ್, ಇಫ್ ಯುವರ್ ಡಿಸೈನ್ ಇಸ್ ಓಕೆ, ಐ ಮೀನ್ ಟು ಸೇ, if you have selected 8 also, you would be awarded marks, don't worry about it. If you observe the scheme of evaluation, so it would be given tolerance. So 7, 8 ಈ ತರ ಒಂದು ಕಾಂಬಿನೇಷನ್ ಇದ್ದಾಗ for both the things you'll get the marks. ಅದ್ರ ಬದಲು ನನಗೆ 14 ಬಂತು, 14 ತಗೊಂಡಿದ್ದೆ ನಾನು, 14 ತಗೊಂಡ್ರು ಸಹ ನನಗೆ 55 ಕೆಳಗಡೆ ಬರ್ತದೆ. ಒಂದು 2 3 ಅಪ್ಲೈಡ್ ಸ್ಟ್ರೆಸ್ ಬರ್ತದೆ ಅಷ್ಟೇ 14 ತಗೊಂಡ್ರೆ. ಸೊ ನಾನು 14 ತಗೊಂಡಿದ್ದೀನಿ, ಇಟ್ ಈಸ್ ಆಲ್ರೆಡಿ ಲೆಸ್ ದನ್ 55, ನನ್ನ ಪ್ರೊಸೀಜರ್ ಏನಕ್ಕೆ ಕರೆಕ್ಟ್ ಅಲ್ಲ, ದೆನ್ ಇಟ್ ಇಸ್ ಅನ್ ಇನ್ವ್ಯಾಲಿಡ್ ಆರ್ಗ್ಯುಮೆಂಟ್. ಐ ಕ್ಯಾನ್ ಸೇ ಇನ್ವ್ಯಾಲಿಡ್ ಆರ್ಗ್ಯುಮೆಂಟ್ ಆಗುತ್ತದೆ. when it is very much closer, then I can accept it. ಇವಾಗ 7mm ಮಾಡ್ಯೂಲ್ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಇದ್ದು ನಿನಗೆ 8mm ಮಾಡ್ಯೂಲ್ ನೀನ್ ತಗೊಂಡಾಗ I can agree upon that, no issue with the design, and design would never give you the exact values. Keep this in mind. ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ಲರಿಗೆ? ಇನ್ನೂ ಏನಾದ್ರು ಡೌಟ್ಸ್ ಇದೆನಾ ಈ ಮಾಡ್ಯೂಲ್ ಡಿಸೈಡ್ ಆಗೋದ್ರಲ್ಲಿ? Still there are any doubts?
sir.
ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ಲ? ಸೊ ದಿಸ್ ಇಸ್ ದ ಕೈಂಡ್ ಆಫ್ ಸಬ್ಜೆಕ್ಟ್. ಇವೆಲ್ಲ ನಾನು ಬುಕ್ ಅಲ್ಲಿ ಬರ್ಲಿಕ್ಕೆ ಆಗ್ತದಾ ಅಥವಾ ನೋಟ್ಸ್ ಅಲ್ಲಿ ಬರ್ದ್ಕೊಳ್ಲಿಕ್ಕೆ ಆಗ್ತದಾ? ಈ ಎಲ್ಲ ಡಿಸ್ಕಷನ್ಸ್ ನಾವು ಇಷ್ಟೊತ್ತು ಮಾಡಿದ್ವಲ್ಲ, ವೆದರ್ ಇಟ್ ಕಾನ್ ಬಿ ಗಿವನ್ ಇನ್ ಅ ಫಾರ್ಮ್ ಆಫ್ ಎ ನೋಟ್ಸ್? ಡು ಯು ಥಿಂಕ್?
No, sir.
ಡೆಫಿನೆಟ್ಲಿ ಅದು ಆಗಲ್ಲ. when you talk, when you learn, when you solve, you'll come to know the beauty of the subject on the exact right way to do the problems. Okay? Idagli Ramayana. Next, what do you have to do? What is our next thing to be calculated? I think both the things have been asked, the bare load as well as the dynamic load. First we shall calculate the dynamic load. And ಯಾರ್ಯಾರು 7 ಅಲ್ಲಿ ಫಿಕ್ಸ್ ಅಪ್ ಆಗಿದಿರೋ 7 ಗೆ ಮಾಡಿ ತೊಂದ್ರೆ ಇಲ್ಲ, ನೋ ಇಶ್ಯೂ. 8 ಫಿಕ್ಸ್ ಅಪ್ ಆದವರು 8 ಗೆ ಮಾಡಿ ತೊಂದ್ರೆ ಇಲ್ಲ, ನೋ ಇಶ್ಯೂ, ವಿಲ್ ಗೆಟ್ ದ ಮಾರ್ಕ್ಸ್. Dynamics. I mean dynamics ಅಲ್ಲ, dynamic load. ಸೊ 1 or 2 ಮಾಡ್ಯೂಲ್ ಎಕ್ಸೆಪ್ಷನ್ ಇರುತ್ತೆ ಕಂಡ್ರೋ. ಸಪೋಸ್ 7mm ಮಾಡ್ಯೂಲ್ ನೀವು ಫಿಕ್ಸ್ ಮಾಡಿದೀರಾ, ಅವನ ಆನ್ಸರ್ ಶೀಟ್ ಅಲ್ಲಿ 8mm ಮಾಡ್ಯೂಲ್ ಇತ್ತು, ದಟ್ ಈಸ್ ಅಕ್ಸೆಪ್ಟಬಲ್. ಜಸ್ಟ್ ಯು ವಿಲ್ ಚೆಕ್ ಫಾರ್ ದ ಡಿಸೈನ್ ಸ್ಟ್ರೆಸ್. ಇಫ್ ಇಟ್ ಇಸ್ ಲೆಸ್, ಸಪೋಸ್ 50.9 ಇದೆ, ಕಮ್ಮಿ ಇತ್ತು ಅಂದ್ರೆ ಆಯ್ತು, ಇಟ್ ಇಸ್ ಅಕ್ಸೆಪ್ಟಬಲ್, ನೋ ಇಶ್ಯೂ. 7 or you can go for 9 also. ಹಾಗಂತಂದ್ಬಿಟ್ಟು you cannot go for 20, 15, 14. Those are all not acceptable. Okay. Dynamic load ಗೆ ಬನ್ನಿ ಈಗ. Dynamic load calculate ಮಾಡಲಿಕ್ಕೆ what is the formula? That is FD is equal to FT plus K3 V C into B plus FT divided by K3 V plus square root of C into B plus FT. I guess you know the value of FT. For whatever module you have selected, you just take that. And those are solved for 8 module, you can just give me the value. I would take that. FT value ಎಷ್ಟಿದೆ? Uh, 4144.66. So that is the FT value. Next. From where do I get the K3 value? It is directly given in the book, I guess. It is 20.67 from the data handbook itself. Very good. How do I get the K3 value was done? Next. How do I get the C value? How do I get the C value? 12.12 C value. ಏನದು 12.12? Okay. Table number 236. Okay. I wish I would have a separate this thing. Table ಗೆ ಒಂದು separate ಇದು tab open ಮಾಡಬಹುದಲ್ಲ. Okay, ಇದು ಬರಲ್ಲ. So you can observe dynamic factor ಅಂತ ಏನು ಕರೀತಾ ಇದ್ದಾನೆ ಇವನು. It has a formula here which has the values of E1 and E2. Okay. You can either go with the table, okay, or you can calculate the things up. So design alli enagutte, listen these words very carefully. Okay. 356 for 7. You carry on, guys. 7 ಗೆ ಯಾರು ಮಾಡ್ತಾ ಇದ್ದೀರಾ? So you can follow two procedures, guys. One thing, for whatever the constant value, there would be a table. A table value. Similarly, ATD ಅಲ್ಲಿ ಕೂಡ ಇದೇ ತರ ಇತ್ತು. ನೀವು ಇದು ಸೂಪರ್ ಹೀಟೆಡ್ ಸ್ಟೀಮ್ enthalpy find out ಮಾಡಬೇಕಾದ್ರೆ either you have formula or you have table. Anything is fine. So second thing, you have be having a formula. So feasibility ಏನು? Formula calculate ಮಾಡಲಿಕ್ಕೆ, formula ಅಲ್ಲಿ calculate ಮಾಡಲಿಕ್ಕೆ certain parameters has to be known. For example, E1, E2, this small e and K1. Suppose if you have a source, ನಿಮ್ಮ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಅವನು ಏನಾದರೂ ಕೊಟ್ಟಿದ್ರೆ E1 ಕೊಟ್ಟಿದ್ದಾನೆ ವ್ಯಾಲ್ಯೂ, E2 ಕೊಟ್ಟಿದ್ದಾನೆ ವ್ಯಾಲ್ಯೂ, K1 ನೀವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು ಫಾರ್ 20 ಡಿಗ್ರಿ ಸ್ಟಪ್ ಡೀಪ್ ಎಷ್ಟಾಗುತ್ತೆ K1 ಅಂತ. ಟೇಕ್ ಇಟ್ ಆಸ್ 8.7. You would get it. Okay. So ಈ ತರ ನೀವು ಪಿಕ್ ಮಾಡಿದಾಗ, suppose if the problem statement ಅಲ್ಲಿ parameters given ಇದ್ರೆ, suppose E1, E2 ಎಲ್ಲ given ಇದ್ರೆ, then you can directly go with the formula calculation. ಇಲ್ಲ, nothing is provided. Okay, you don't have a data for it. E1 ಕೊಟ್ಟಿಲ್ಲ value, E2 ಕೊಟ್ಟಿಲ್ಲ value, then you can go for the table calculation, which you have done for the last problem, remember, I guess, right? So since it's up to you, should I go with table or should I go with formula, or we shall go with both the things and compare? What shall we do?
Table.
Okay. So for this particular problem, I would just try to calculate with the help of table as well as for the formula. Now C is equal to Illodi E divided by, I would take this, write it here and take that up. K1 into 1 divided by E1 plus 1 divided by E2. Idu ondu formula illide. So what I would do, I would just take this particular thing in my notes. Okay. Now, once I have taken this, from the value of K1, okay, here it is. The value of K1 for 20 degree stub teeth is 8.7. So K1 is equals to 8.7. 8.7 for 20 degree stub teeth. I have taken that. Now, you have to find the value of E, isn't it? For E, you have to go for the table, I guess, right? So, what is the table number? Anyone remember it? What is the table number, guys? Page number 236. Okay. 230 to 20. Okay, 12.12, page number 236. Okay, so this directly C value ಕೊಡುವಂತದ್ದು. C value ನಮಗೆ direct ಆಗಿ ಕೊಡುವಂತದ್ದು. Okay, we shall go with E now. ನಮ್ದು velocity ಎಷ್ಟಿದೆ? How much is the value of velocity? 6. So pick this particular value here. Okay, error is how much? E is equal to 0.059. 0.059. Now you substitute the value for calculation of C. 0.059 divided by K1 is K1 8.7 into 1 divided by E1 and E2. Okay, E1 ಎಷ್ಟಿದೆ? ಇಲ್ಲ ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ನಲ್ಲ. So pick these values 207 and 96. Substitute in Newton per mm square and give me the value. So just substitute and give me the values. C value. This particular C value is units is Newton per mm, and this is calculated by means of formula. Always ನೋಡಿ ನೀವು ಟೇಬಲ್ ಅಲ್ಲಿ ಚೂಸ್ ಮಾಡೋದಕ್ಕಿಂತ ಫಾರ್ಮುಲಾ ಥ್ರೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಅಕ್ಯುರೇಟ್ ರಿಸಲ್ಟ್ಸ್ ಕೊಡುತ್ತೆ. ಓಕೆ, now from table directly, even I will write that from table directly.
So the capital E1
even calculate that. ಏನಪ್ಪ E1 and E2 ಅಲ್ಲಿ ಗೇರ್ದು ಮತ್ತೆ ಪಿನಿ ಅಂತ ಕೊಟ್ಟಿದ್ದಾನಲ್ಲ ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲಿ.
ಓಕೆ ಓಕೆ
ಹೆಂಗ್ಸ್ ಮಾಡೋದು ಅದನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋದು. So you be calculating that. I would try to extract the value from the table itself. Okay, so this is the table with what I have. Okay, now error is 0.059. So I can take it for 0.06 error. So I would just highlight this 0.06 error again. Okay, now 20 degree stub ಬೇಕು ನಮಗೆ. So it is cast iron and cast steel, I guess. Correct?
Yes, sir.
Yeah.
Yes, sir.
Cast steel ಇರಬೇಕಲ್ಲ. So cast iron and cast steel ಅಂದ್ರೆ ಇದು. So the value was this particular thing. ಇಲ್ಲಿ 488.4 ಬಂದಿದೆ. So directly ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದಾಗ ಎಷ್ಟು ಬಂದಿದೆ? It is 488.4. This is from the table. See, error ಏನಕ್ಕೆ ನಾವು ಟೇಬಲ್ ರಿಸಲ್ಟ್ಸ್ ನಾನು ಅಕ್ಯುರೇಟ್ ಅನ್ನಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ, ಫಸ್ಟ್ ಥಿಂಗ್ ಕ್ಯಾಸ್ಟ್ ಐರನ್ ಅಲ್ಲೇ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಮಲ್ಟಿಪಲ್ ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್. ಓಕೆ, ಇಟ್ ಮೇ ವೇರಿ ಫ್ರಮ್ 200, ಇಟ್ ಮೇ ಬಿ 210, ಇಟ್ ಮೇ ಬಿ 225. ಯು ಕೆನಾಟ್ ಗೋ ವಿತ್ ಇಟ್. ಓಕೆ, ಅರ್ಥ ಆಗ್ತದ ನಾನು ಹೇಳ್ತಾ ಇರೋದು? ಕ್ಯಾಸ್ಟ್ ಐರನ್ ಅಂತಂದ್ರೆ ಯು ಕೆನಾಟ್ ಫಿಕ್ಸ್ ಅಪ್ ಆನ್ ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್. ಸಿನ್ಸ್ ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ ಇಸ್ ಗಿವನ್, ಯು ಹ್ಯಾವ್ ಟು ಗೋ ವಿತ್ ಫಾರ್ಮುಲಾ ಮೆಥಡ್. This is another way. I am just giving you the comparison, how the things may change. I think it's already time, Allah. Okay. Just give me this value. C value will end up here. 447 Newton per mm. So new table in the calculate ಮಾಡಿದ್ರೆ it is 488. Okay, 4 in the calculate ಮಾಡಿದ್ರೆ it is a table in the calculate ಮಾಡಿದ್ರೆ 488. Whereas when you calculate it from the formula, it is 444. So which I need to take? Should I take it from the table or should I take it from the formula? With the discussion what we had.
Formula.
Why? Because even and E2 values ಕೊಟ್ಟಿದ್ದಾರೆ problem ಅಲ್ಲಿ. When he has given specifically the value of E1 and E2, you have to definitely, without any choice, you have to go with formula method. Okay, so selecting this, please do calculate the dynamic load. By the next class, give me the value, guys. Okay, it's already been late. Kindly mark your attendance and leave. Thank you. Okay, we'll meet up in the next class.